What's up everyone, this is Ryan here. So you're watching part 2 of my Android Kotlin tutorial, and in this video we'll mostly be talking about data. So that's going to include data sources and the repository pattern and just the backend in general. We'll also be looking at a couple features of Kotlin which are built into the language to help us streamline the process of writing several of these classes. And a couple different classes which we'll be looking at today include data models, which are essentially objects our backend will pass around. A validator to make sure that when we pass an expression into the backend to check and see if it's valid, and a calculator to evaluate a valid expression. Now all of these things will actually be spoken to through, well, all is in the validator and the calculator, will be spoken to through the repository pattern, so we'll set up some interfaces to achieve that. So that's basically it. By the end of this video you should have a functioning backend which is loosely coupled to the rest of the application by applying the repository pattern. And I know that might sound like a very basic and not super useful thing if you're a beginner, but just understand that it's very, very important that we be able to change our backend at will and not have those changes sort of propagate and affect the other layers of the application. So that's basically it. Let's hop into the starting point. So I've created two different branches for this project. One of them is going to be master, and one of them is actually going to be a starting point down below. So what I'll have you do is navigate to the Kotlin MVP calculator GitHub repository. Link will be in the description box down below. And so what I would recommend you do is probably you'll want to clone and download both the master branch, which is essentially the completed application, and also the starting point branch. And so the starting point is basically where I will be starting the tutorial off, and you're going to want to navigate to that because it has a lot of the different things that we're not really going to be worrying about in this tutorial sorted out. Might be worth looking. So I basically borrowed a method of managing Gradle from the Android architecture components repositories. And essentially how that works is we create a versions.gradle file, and we essentially host all of our different versions in one file here, and using some Gradle groovy magic, basically manage all of our dependencies for a multi-module project in one area. Now this is just a single module project, but it's kind of good to get in the habit of practicing for multi-module builds, because that's sort of more how we're moving towards building applications in the future. Anyway, since this is a smaller application, we don't really need to worry about that. So what I'll have you do, like I say, at the very least, you're going to want to clone or download the starting point here. You can actually do that in Android Studio. Let me just pull it up here. So one of the ways you can do it is you can go to File, New, and then you can say Project from Version Control, GitHub. Just input the appropriate URL here, and you can create it that way. So that's basically it. So I'm going to assume from here on that you have done that, and we will get into coding some classes. So the first thing we're going to do is let's just create a couple of different packages for our application. So for starters, I'm going to go ahead and right click on the calculator package. We're going to go to new package, and we'll call this one data. We'll create another one called domain. We won't be talking about domain too much in this particular video, but we will touch on that. Within domain, you're going to create a couple different packages here. So the first one is going to be called domain model, not domain model slash, my apologies. And the next one is going to be repository. So this repository folder is where we will hold the interfaces for the backend, and it will sort of help us create a decoupled repository pattern sort of setup. Anyways, within the data package, we're going to right click on there, go to new package again, and we'll make a package called data model. So one of the things I want to mention right off the bat here is that we're going to have different kinds of models, and we'll see what those are in a moment, for different parts of the architecture, and we're doing that based on what makes sense. So in many cases, when you're working with a specific API, you'll have sort of data model classes which are tightly coupled to that API. So maybe you're using Room database and you've got a couple different annotations in there or something like that. Well, we don't really want the rest of our application to know what specific backend solutions we're using. Instead, we can create these classes in a way where everything is sort of separated and decoupled, and we can change one part of the application without having to change the other. And one of the ways we can achieve that is through using different model classes for different parts of the application and the repository pattern. So we're going to make one more folder here in domain, and that's going to be use case. And that's basically it for the package structure to begin with. Okay, so we're going to get started writing our data model classes. Now, one of the confusion points which a lot of people run into is the difference between data and model when people are speaking of model view presenter. So in this particular case, the thing about it is whether it's a small class with a couple getters and setters in Java or the entire data management portion or layer of an architecture, it all has to do with data, and so that's generally what people would call the model. My style is a little bit different, although in a way they're not, because it's always related to data. But I like to call my layer the data layer, and I like to call the sort of specific little classes that just sort of hold data and tend to get passed around the application as models. And then from there I have a data model for the backend, domain model for the sort of interactor use case layer, and then like a front-end UI model or view model or some such thing. So just so there's no confusion there, when I say data model, domain model, etc., I'm basically talking about a data container class. Anyways, enough rambling, let's get started here. So within data model, right-click on there, go to new, Kotlin file, of course, and we're going to call this file expression data model, like so. Just make sure we don't add anything to the starting point repo here. So let's get started with a little bit of basics of Kotlin, which is one of the things I wanted to touch on in this video. So for starters, one of the things which is pretty damn handy about Kotlin is that it basically has a specialized keyword for these model objects that I was just talking about, and that keyword is data. So we're going to call this a data class. Let's zoom in a little bit here. Data class, and it's going to be called, of course, expression data model. Now, there's a couple different sort of idiosyncrasies with Kotlin, which I'll talk about in a second here, but just follow along with what I'm coding. So we're going to add some parentheses to the end of the class name here. And within these parentheses, I'm going to say val, value, that's creative, string, and then we're also going to create a second value called isValid, and that's going to be a Boolean. So if you're totally new to Kotlin, or if you're coming from Java, then there's going to be a couple things which are probably freaking you out right now. So let me just go over them really quickly. So there's two ways to create what I'll call fields. You might call them variables in Java. There's two ways to create fields in Kotlin. So the first keyword is var, and the second keyword is val. So var is going to be basically a value, or actually we'll say field, a field which is mutable, which is a fancy word for changeable. I'm having a great time typing today. And then val is for a read-only field. So that's going to be pretty similar, I'll just make a note here, similar to like saying final in Java, but not exactly the same. So basically, when would you want to use a var or a val? Really simply put, I don't actually want these things to change once the object is created, and therefore I'm going to make them read-only values. So that's basically that there. A couple different other notes. So we kind of have slightly reversed syntax from Java. So for example, let me just copy over a quick little cheat here. So as you notice when we're declaring these values, so we have the keyword, so that's going to be val or var, and then we have the name of the val or var that we're creating, and then we have the type or class. So this is kind of like a little cheat sheet here for you, or a quick reference for how we sort of stylize creating these fields in Kotlin. So just really quickly, and you know, if you're coming from Java, yes, this will feel awkward at first, but you'll get over it after about 2 weeks if you just practice it. So basically what we do is we have the name of the variable or field first, and then followed by the type. Now, the last thing that I'll kind of mention is that the parenthesis, we'll see if I can spell that correctly, the parenthesis which follow the class name work similar to a, and my face is probably blocking what's going on here. Let's just do that. Works similar to a constructor in Java. So as opposed to having our typical constructor class down below called something like class, expression data model, blah, 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 instead what we can do is we can do most of that work just within the parentheses. Now, I won't show this sort of in detail now, but you can do a lot of different things within these parentheses. So we could, for example, assign values, so blah, at runtime, and then that way we wouldn't actually have to pass that value into the parenthesis. You can just do a lot of different things, but by setting up this way, we're essentially saying we have this class called expression data model, and we're expecting it, when it's created, to be given these two values, which will be saved as read-only, or as values. So that's basically it. The last thing that I wanted to mention is that this data keyword here gives us access to essentially a whole bunch of boilerplate code which we don't have to write. So what I'm trying to say here is we're actually done writing this class, which if you're coming from Java, you're probably like, really? This is actually all we need to write here. So by adding this data keyword here, it's going to give us extra access to like getters and setters and copy and toString and a whole bunch of stuff that we would have to manually add to Java. So that was one of the first things for me where I kind of saw, okay, well, this is a little bit of extra time, which I don't really need to spend writing code out, which I'm always happy to do. So that's basically it for writing the data classes. What I'll do is I'll kind of skip ahead and write the other data classes within the data model package. We'll just go over them really quickly, but it's not very interesting stuff. So yeah. So I'll just spend one quick moment talking about the other two data models. So we have operator data model and operand data model. So essentially these two model classes are different ways I've chosen to represent an expression, a mathematical expression to be precise. And so essentially when we have an operator, which can either be multiply, divide, add, or subtract, we essentially assign a value to this class based on whether it's add, subtract, multiply, or divide. And so, of course, if it's multiply and divide, we want to consider that as something which should be evaluated first next to a lower priority operator as per bed mass. So that's all that's going on there. And then for operand, we're really just talking about a number which could have a decimal point. So we're thinking 1, 10, 2.3, 37. Doesn't really matter. And so those are sort of the two different classes which decompose an expression. So the next thing we're going to do is we're going to talk about the repository pattern really quickly, because it's actually very simple and saves you an enormous amount of headache. So I've got this little diagram up on the screen here, and basically here's how I want you to think of it. Essentially we've got this logic class here, so this could be like a presenter, or it could be a use case, or something, whatever. It's a thinking part of the class. And then we basically have these two data classes or data sources out here. So in this particular case, let's say we have like a Firebase database for remote, and maybe we have like a Room database for local. It doesn't matter. So this is really what the repository pattern is in a nutshell. If we're not applying the repository pattern, then our logic class or whatever class is using these classes talks to them directly. Whereas the repository pattern, and this really is all it is, it's also known as the Facade pattern in other circles. Essentially what it is whatever class that needs to talk to, say, a backend service or just some other class, when we want to hide the finer details of what's going on, we can apply the repository pattern by having that class depend on these other classes through an interface. Now, it's really quite simple. I will mention if you're not sure what an interface is or how amazingly useful they are, what I've done is I've posted a link in the description box for my sort of 30-minute explanation of what an interface is in Java. Now, in that particular video, I give you sort of a clear example and demonstration of how interfaces can help you sort of modularize your code. So you're going to want to check that out if interfaces are unclear to you. However, we're also going to be building this stuff right now, so maybe watch this video first, and if you're still not clear on what's going on, go ahead and hop into that video later. Anyways, let's move on to the repository. So what we're going to do here is we could actually choose to implement this class in the data layer. One little trick I picked up from my friend Darrell is to actually include the interfaces for the backend data layer in the domain layer. Now, when we're thinking domain, I'll talk about this in the next episode, but domain is sort of stuff which is quite decoupled from the front end and the back end. It's essentially a very raw form of data and instructions. And since our interfaces won't include any kind of APIs within them, they're essentially just collections of method stubs or function stubs. That would be the kind of thing that I like to see in the domain layer. So anyways, again, you could do it a little bit differently, but that's just sort of the way I've picked up on doing it. So what we're going to do is we're going to right-click on repository, go to new, Kotlin file or class, and I'm going to prefix these classes with the character I. So we're going to say I calculator, and then we're also going to say I validator. Now, one of the things to note here is that essentially this I basically just stands for interface, and as we'll see in a moment, the classes which implement a particular interface will be suffixed with the 4 characters IMPL. We'll see that in a moment, but let's just get started writing these interfaces here. So we'll start with validator. So what we're going to say is we're just going to type interface I validator. Now that is exactly the same as you would do it in Java, and Kotlin sort of uses interfaces in a very, very similar way. One little change here is in order to write our method stub, we're going to say fun validate expression, which is the only thing this particular class will do. We'll pass in a value called expression, which will be a string, and I want this method stub to return a Boolean. So this is another little sort of syntax with Kotlin. So in order to, I'll just write some notes here, to set up a method slash function. In Kotlin it's called a function, but in Java we generally call this a method. So we have the keyword fun to denote function. We have the name of the method, and again we're using camel case. And then we have the parameters, the parameters for the function. And again, we're using that sort of reversed syntax. So we have the name of the parameter followed by the type. And then this second colon here refers to the return type over here. So essentially we're saying we want a function, a method called validated expression, which gets an expression string passed into it, and it will return a Boolean value. Now, as you can see, there's nothing special going on here. There's no APIs or anything like that. So this is sort of why I like to put this, say, in the domain layer. Anyways, yeah, so this is all the validator does. We're basically saying at some point we want a class to implement this interface, and the one thing we will require this class to do is it must have this particular function. How it actually implements the function is up to the class itself. So what we'll do next is we'll just write the calculator. This one's a lot more difficult and involved than the previous class. So we're going to say I calculator, and we're going to say fun evaluate expression. Again, it's just going to accept an expression string. And then we're also going to return something a little bit different here. So this is when we're getting into the RX Java magic. So one of the things about this is that our validator is going to operate synchronously, and then our calculator is going to operate asynchronously because it might take a little bit of time. I didn't really have to do this because I don't think it ever would time out, but what we're going to do is we're going to work in some RxJava magic here, and we're going to say flowable of type expression data model, which is that class we created earlier. Now, we'll be talking extensively about RxJava later on. If you're familiar with live data, you could use live data here as well. Essentially, what we're saying here is we don't want to basically just return and operate things synchronously. We actually want it to occur asynchronously. And how we achieve that is instead of returning immediately an expression data model, we return a flowable which will eventually emit the value we want. So again, I'll talk about that extensively later on, but that's really all that's going on there. So that's basically it for our repositories. What we will do next is we will write out some portions of the implementations of these repositories. Okay, so the next thing we're going to do is we are going to write the classes which implement our repositories here, our interfaces. So in the data package, right-click, go to New, Kotlin file or class, and we're going to call the first one Valiator impl. So whenever you see this impl keyword here, that essentially stands for implementation as opposed to an interface or an abstraction. So just simply put, an interface is like an abstraction of a concrete class, and it's an abstraction because it contains less detail, whereas implementation is the actual lines of code necessary to implement a class which can inherit from an interface. So really we have two things going on: abstraction, implementation, sort of more theoretical and vague, idea-based, and then we have concrete. So hopefully that's clear. If not, you can let me know in the description box below or hop on the live Q&A every Sunday. Oh, well, most Sundays, but yeah, that's basically the difference between interface and concrete, or abstract and implementation. So we're going to create validator impl. Now, I'm not actually going to write out all of the code for these classes because it's just not very interesting. It's validation logic and calculator logic, but we will write part of it. So the first thing we're going to do is I'm actually going to make these classes as objects. And now, why would I want to make it an object? Essentially, the object keyword in Kotlin sort of acts like a singleton. We're basically saying I do not want multiple instances of this backend class operating at the same time. I just want one instance of them in a given time. So we're going to say object validator impl. Now, the way that we inherit from a superclass or an interface is we write out the name of the class, followed by a colon, and then we'll say the interface or the parent class which we want to inherit from. So in this case, we want iValidator. Also going to add into just little brackets there. So it's showing up as red because we haven't implemented the particular method. So I'm just going to go Alt-Enter, implement members, validate expression. And that's going to do most of the work importing our interface over, but there's still a lot of different boilerplate code to write. So what I'm going to do is I'm actually just going to copy and paste the rest of the code in. We'll just talk about it, and then we'll do basically the same thing for calculator. Like I say, it's not the most interesting code. So first and foremost, let's just copy in the body of this method here. And then I will add in all of the different validation methods that I've included. And if you haven't done so, again, I would really recommend that you have the completed project on one side if you have dual monitors, or just at least have the completed code visible in a browser or in Android Studio so you can copy and paste this over, as I do. So, yeah, like I say, there's not a whole lot interesting going on here. So we've got a bunch of private functions which are only visible to this particular object. And these are basically different ways to validate whether an expression is valid. Now, this isn't necessarily exhaustive. All I'm really doing is we get our expression passed in, and then I pass it to a bunch of different helper methods here. And if any of these helper methods find that the expression is invalid, then we basically return false. Otherwise, if no incongruencies are found, then we return true, which is basically the validator saying this expression is valid and can be sent to the calculator. Now, like I say, this is not very interesting code to write, and I didn't actually set out to cover every possible case. If you really want to break the calculator app, you probably can. It's just a demo. But I did cover most cases. So, for example, we don't want an expression to start with an operator or a decimal point. We don't want repeating decimals. I won't talk about this too much, but one of the neat things about Kotlin is it gives us access to all kinds of neat methods. Like here we have essentially, we're taking an expression and sort of turning it into a collection by using this .indices property here. And then we're saying for each character in the expression, we want to run some kind of function on it. So essentially what we do is we check it, I believe, stands for iterator, but this is essentially, let's say, the first character. And what we're going to do in this particular function is we're going to say, is concurrent decimal first character we're looking at? So let's say we're evaluating the expression 1 plus 1. So essentially what it would say here is, actually let's say 1.0 plus 1.0. So in this case we would say, we would get to the decimal and it would be point, and then we would check the next sort of character in that little expression and we would find that it is a 0, so it would pass. Otherwise, if we said like 1.0, then it would fail this particular check. So I won't go through all these, but just to give you an idea of the type of stuff that's in here. And yeah, we just go through and check that. So writing the calculator class was a lot more involved than writing the validator, and it is a little bit uglier code. So what I'll do is I'll take you through the main method and then we'll look at the helpers really quickly. So essentially what we do is we pass in our expression as a string into the evaluate function, and then we have our helper methods to basically decompose the expression into operators and operands, and then we perform all of this ugly code to basically iterate through the two collections and evaluate them as appropriate. Let's just hop down to the helper methods, because this is really the only useful code I wanted to talk about here. So this little magic here, so first off, we have a couple different Kotlin methods which operate on collections. So what we're doing here is we're saying expression.split. So we're basically going to split the expression based on these delimiters into a collection or an array list based on the input of the expression. So we separate it out into operands, which is pretty handy. And then what we end up doing is once we have sort of separated the expression, then we output that particular collection into a new collection called output. And how we do that is we say operands.indices, so that basically stands for each element in the sort of collection, mapTo, and we're mapping it to output, which is like a mutable array list here. So we're saying take each of these and map it to a list which contains operand data models. And in this little area here, this is where we actually perform the operation of mapping from, say, part of an expression to this operand data model class for each of these items. And IT, I believe, stands for iterator, but it basically stands for the current item as the sort of map to operation loops. So that's it for get operands. Get operators, again, we're applying this little split method here, and we have some regex code. If you're not familiar what it is, it stands for regular expression. And what we can do is we split the expression based on numbers, and including decimal numbers. We filter out any emitted value, which is just like a blank value. So again, this is really handy, just some Kotlin syntactic sugar here. And then we're going to say, I want to wrap all of that and put it into a mutable list, which is of course called output. And then again, we're performing that mapTo operation to convert from, say, a character or a string value to an operator data model value. And then down here we have the actual code where we evaluate a particular pair. which is going to be a pair of 2 operands and an operator. So that's basically it for the calculator class. Again, I really didn't set out to build the most amazing calculator evaluator thing out there. I just wanted to build something pretty quick and legible. So yeah, that's pretty much it for the calculator impl. Alright, so to recap the video, we looked at a couple different ways to write Kotlin syntax and keywords, which is similar but a little bit different from Java. And already we've seen some cases where Kotlin has really saved us a whole bunch of boilerplate code, which we normally would have had to write in Java. We've set up our backend so that it will be communicated to through an interface, which is essentially what the repository pattern is. It's hiding an implementation through an interface, more or less. And lastly, we've implemented the backend. We've put in the concrete implementation of the repository interfaces that we created, which will allow us to actually validate and calculate an expression. So that's it for this video. Thanks for watching. If you enjoyed the content, please do me a favor and hit the like button down below and consider subscribing if you haven't already. So that's it for today, and thank you for watching.